Good morning, all. Welcome, and we will just give a minute or two to make sure we have everybody coming in the gates here for our information session. All right. Well, Adet Yahuds, welcome all. Welcome to our 44th information session on the coastal flood mapping and planning part 3. I'm really excited to be back and be hosting this webinar with you. This webinar is being hosted by the Alaska Climate Resilience Learning Network under the Alaska Climate Adaptation Science Center in partnership with the Native American Fish and Wildlife. And with all of our sessions, it's being recorded, so you can access it later on our website. And just to start, for this session, we have a few reminders. If you're calling in, please mute your phone. If you don't have a dedicated mute button, press *6, and this should mute your phone. If you're using a computer audio, all participants have been muted, and during the question and answer session, you'll be able to mute yourself to ask any questions, or unmute yourself, excuse me. You can also enter your questions into the chat, and we will read your questions out loud. So we invite those of you who are able to access the chat on Zoom, please introduce yourself, tell us where you're from, what tribe you're with, or what organization or agency you're with, and what do you love about winter? That would be a good one. We are getting snowed in Fairbanks. And so I just want to let you know again, today is February 18th, and we're here on the information session for coastal flood mapping and planning, part 2. So Alaska is all indigenous land historically, as is the rest of our country. And in Alaska in particular, where we are at the International Arctic Research Center, which is where the Alaska Climate Adaptation Science Center is at, is on the Trothiada campus at the University of Alaska Fairbanks, and that means the Indian Potato Ridge. And this name was officially given by Chief Peter John a couple of decades back. And the one thing that I wanted to share this morning, because if you look at the left-hand upper picture, it's the boat landing down across from Howard Luke's, and I think that's my boat right there. But I frequently walk down there. But yesterday I ran into Howard Luke's map, and on the map he has all the traditional place names around this Tanana Valley area here in Trothiada, and he said that the Indian Potato Ridge is the name of this area, but they often found the potatoes around a lake called Smith Lake now, where there's a lot of skiing. And that was where they harvested a lot of that troth. And so just thought I'd share a little different story about the land. We also have folks who are in, as part of our team, Denaina Ithlan down in Anchorage, and in Shaktoolik. And so we have a wonderful team of people we've been working together with for quite a few years now under the Tribal Resilience Learning Network. Some of us are joining us, some of them are joining us here today. And so hopefully you recognize a few of us. We do have some changes here at the Alaska CASC, and are adding increasing teams, and just had a change with our new director, Kristen Tim. So I thought I'd share that. At the Tribal Resilience Learning Network, we really try to support tribes in a number of ways. Of course, you're welcome, for those of you who are with tribal governments, and want to be exploring issues around climate for one-on-one check-in calls, providing we can provide some technical assistance on that. We have a regular e-bulletin. Hopefully all of you are signed up for that. Please go and do that if you haven't and you'd like to hear from us more. We have, of course, these information sessions, and as I mentioned, this is our 44th one. And then a slice of our team is involved in the relocation, manage, retreat, and protect in place cohort training that we do with other partners. And if you'd like to learn more about us, of course, you can visit the website where we often have a lot of announcements and additional resources. So I just want to make a couple of announcements here, and I'm not sure if our presenters are also going to make the same announcement, but that's okay. The Alaska Tribal Conference for Environmental Management, which many of you may attend, it's also known as ATCOM, is happening March 24th through 27th, and the registration is open right now. And while we have this part 3 presentation today by our guest presenters, we will also be providing a workshop during ATCOM on this tool. And so that will be March 24th from 2:30 to 5 p.m. And we encourage you to bring a laptop. It's under the resilience track. And the title is Supporting Community Planning for Coastal Flood Hazards with New Products and Tools from USGS. Quite a mouthful. So here we are with our guest presenters. I'm really happy to introduce Lee Erickson and Maya Hayden. They are from the USGS Pacific Coastal and Marine Science Center. They've presented with us previously. We have a part 1 and a part 2. You'll see the dates that those were offered. Those are under our information sessions. I highly encourage you to go and listen to those. During both of those, part 1 and part 2, we had community and tribal representation presentation involved. And unfortunately, today we had hoped to have that same representation, or at least regional representation, from the 4 villages in the Quirk region, but they have quite a few meetings happening up there, and many of the leadership from those communities are attending some of those meetings. So those two, part 1 and part 2, are well worth watching and getting a better sense of how this whole work with the communities on flood mapping has unfolded. So I think, whoops, I will do an escape there and stop sharing and turn it over. Maya, are you on first, or is Lee up?
Lee is up first, and I'm going to share. All right. Take it away, Lee.
Okay. Thank you, Maya. And thank you, Melinda. Thank you, everybody, for being here today. We're glad and happy to share some updates that we have. The title is New USGS Tools to Support Planning for Changes in Coastal Flooding. And we can go on to the next slide, please. So I'd like to just start with what we all remember very vividly back in October, when ex-typhoon Halong hit the South Atlantic coast of Alaska. The video that you see there on the left-hand side is a video of the wave heights that were formed. And this typhoon formed offshore of Japan and worked its way up, right? And then it hit the Kuskokwim Delta there and impacted several communities. Those are highlighted primarily with those cyan-colored circles. And it was devastating, right? 1,400 persons were displaced, and very devastating consequences, and hundreds of homes damaged and still undergoing repair. And that kind of event begs the question of how resilient structures should be built. Should they remain where they are? Should they be moved? Should they be raised? These are all things that we have to plan for the future. In looking at the data and the impacts of Heilong, we can say from the modeling that we've been doing that for Utqiagvik Bay, at least, Heilong was about a 50-year storm. And we can say that with the figure that you see there on just to the right of the video. That figure there is what we call a flood staff. And on the left-hand side, you see elevations, which is feet above mean high water, and the established minor, moderate, and major impacts depending on the elevation of the water level. And then the numbers there, the RP 5, 10, 20, 50, and 100, those are the return periods. So if we look at the RP 50, for example, that's a 50-year return period storm, or has an annual exceedance level of 2%. So it's the same as saying that there's a 2% chance of it happening every year. And if we plot the high water marks that were measured in on the ground by J-way surveys and commissioned by DGGS after Heilong, that's how we can see that, okay, this was a 50-year return period storm. Can we go to the next slide, please? But what do we really mean by a 50-year storm? So I just thought I'd take a minute here to explain that, or try to highlight it a little more. Imagine that you have a jar with 50 marbles, where each marble represents a year. And imagine that just one of those marbles is blue and represents a nasty storm. You close your eyes, you stick your hand in, and you grab a marble. Chances are you're going to grab a yellow marble, but perhaps you will grab that blue marble, which will then be the crazy storm that happens. You then close your eye, or then you put the marble back and you shake up the marble, and you do the same thing next year. So that means then that every year you have a 1 in 50 chance that that storm is going to happen. And the same thing goes for the 100-year. You have 100 marbles, but now your chances of pulling the blue marble is even lower, right? But it's a bigger storm. And let's go to the next slide, please. So what I showed you before was that flood staff, where Heilong elevation was at about a 50-year return period for 1979 to 2022, so the recent past. But we've also been doing a lot of modeling and looking forward in time, 2020 to 2050, and doing probability casting going forward, so beyond 2050 even. And then you can see that that same elevation is actually now more like a 30-year return period storm, or has a 3% chance of happening any year. So there's a higher chance that Heilong type storms are going to be happening in the future going forward. Next slide, please. And as I mentioned, how did we get to those answers? Well, we've been doing a lot of numerical computer modeling. We start on the global scale. There it is. Thanks. We start on the global scale. And that's so that we can catch the storms that are everywhere. So the storms that start in Japan and work their way up the coast and make it over to Alaska. So we go from global to regional Alaska coast, and then down to the local community scale. And at the community level, we're modeling really detailed phenomena. We're doing 3 feet resolution. So we're computing waves and how waves are running up on the shore, and we're computing how water moves over land and how the storm surges hit against the coast. And as you see, we're doing that from 1979 all the way to 2050, and we're doing that with a suite of climate scenarios for the future. And if we can go to the next slide, please. So on that local scale, we have individual, very detailed models for each of the communities. These are high resolution, they're tailored with local bathymetry and topography. They resolve key processes, the storm surge, the waves, how they run over land. And that predicts impacts, not just water flowing, but also erosion and velocities. And the image that you see there on the right, or the video that you see, is of Unalakleet. That's one simulation there. And you can see, if you look really closely on that top, you can see the waves going from left to right and going up on the coast and through the inlet in Unalakleet and back to the backside as well. On the bottom is a transect, which is that transect A to B that you see in the top figure. And you can see there the waves are coming from the left side, right, and hitting the coast there and running over the dune. And next slide, please. So for each of these community-specific models and domains, we run scenarios, storms that have already happened. And we do this to compare against measured values of where flooding has occurred. And if you look here on the right-hand side, you see examples for Elim and for Unalakleet, where we compared to the Merbok storm in 2022. And the red marks there are the measurements, and the blue see-through color is what we modeled. And after some calibrations and that, we feel very good about how this model is performing, as you can see. So we get doing this kind of past storms, we build confidence for these models. So now we feel like, okay, we have this confidence, we can now look into the future and use forcing winds and sea ice conditions for the future. So we run the future cases for a suite of storms, future storms, the annual 1 year, 10 year, 20, 50, and 100-year future storm that we gathered from our global to regional and local scale modeling. And we do that with 4 different separate climate models so that we can take an average and look at the variability between them. And each of those storms we run first with no sea level rise, and then additionally we run that on top of, another click, Maya, please, on top of those sea level rise, 5 additional sea level rise scenarios that you see there. So we end up with, I think it's 36 combinations. Yeah, let's go on to the next slide, please. And why do we do so many combinations for the storms on top of the sea level rise, rather than just saying, oh, okay, well, in 2060, it's going to be such and such sea level rise, and that's when we think it'll be that storm. Well, we have that storm, like I mentioned before earlier, can happen any year, right? It's just a smaller probability for the 100-year storm, but it can happen this year, it can happen 10 years from now, or 100 years from now. And it can happen for different sea level rise scenarios. So let's say, for example, that we're planning to build something with a 50-year design life. So it should last out to 2075. If you click next, please. So if, well, it seems then that if we consider the intermediate scenario for sea level rise, that what I should say is, sorry, these sea level rise curves are based on measurement. They've been compiled from data, observation data. Sea Level Rise Task Force spent a lot of time putting these together, and they account for melt, land-based snow melt, making it into the ocean, and rising in thermal changes and such. And they have this for all over the globe. And this particular graph is for Nome. And so that I drew the line here, actually Maya drew the line, at 0.5 meter. So if you're planning for a 50-year design out to 2075, and you think, okay, well, let's look at the intermediate scenario. And that's where the intermediate and intermediate low and the high scenarios, those are different examples of emissions that include how much pollution we put into the air and volcanic eruptions, etc. So if we think that's we're following the intermediate track, then you could see that at 2075, the 0.5 meter sea level rise seems appropriate, but it could happen as early as 2055 if the high emission scenario continues. And next slide, please. So in summary, what we've been doing is at the local scale, simulating flood hazards for a suite of future storms in combination with different sea level rise. Out of these very detailed community-based models, we get flood extent, the minimum and maximum extent, uncertainty bounds, the flood depth, wave height, velocity hazards, shoreline change, and then we overlay that with different infrastructure and houses and such to assess socioeconomic exposure metrics, we call them. And that we've been working on in putting into a web tool that Maya's going to talk about.
Thanks, Lee. Okay, so I'm going to switch over and start talking about applications for these flood hazard products. What kinds of decisions can this information really help to support? And I'm going to run through a couple of examples. So I think probably a lot of you are familiar with the unmet needs report and this graphic of thinking about ways that communities can, think about being more resilient to coastal flooding and erosion hazards. Everything from protecting infrastructure in place, that might mean elevating buildings or putting up shoreline protection, managed retreat, meaning actually moving certain structures, further potentially away from hazard zones, and then all the way to complete community relocation. And so the kinds of information that these flood hazard maps can provide is in thinking about, which buildings are at risk, both now, but also thinking about the future with climate changes and rising seas. Which of those buildings might be at risk? And then also thinking about, elevations. How high does shoreline protection actually need to be to protect certain structures, even with, a certain amount of sea level rise? And then how high should, for example, homes be elevated? And then when we're thinking about actually moving infrastructure, then we want to know, okay, well, what areas are away from or outside of both the current and the future flood hazard zones so that we can avoid building in areas that will be at risk in the future. So as an example, I'm showing, this is a map of Elim, and currently you're looking at the no sea level rise in an annual storm event. So this is water levels that pretty much every year get to be this high. And so the question that we can start to ask is, okay, what is the extent of coastal flooding that we expect during an annual storm? And then how does that flood extent change with bigger storms? And so now I'm looking at a 20-year event. You can see that water starts to move into this low-lying area through a culvert. And some of these structures may potentially be within that flood hazard zone, and you can see even what depth the water might be in that 20-year storm frequency water level. Now we move on to this big 100-year storm frequency. This is something for Elim that was approximately like what they saw for Typhoon Merbok. And thinking about, what structures or houses, roads might be at risk. Okay, so now we're going to think about not just that big storm event, but how are water levels expected to change with increasing sea level rise? So now we're going to start increasing sea level rise and keeping this 100-year storm. So if we move to 1.5 feet of sea level rise, you can see that there was some expansion of that flood footprint. Also areas that are getting deeper. And then if we move to that kind of just over 3 feet of sea level, you can start to see, some additional flood extent as well as areas that get deeper. So you can start to think about, okay, what things might be within these hazard zones in these different combination of scenarios. So I'll give you an example. We know in Elim, they're thinking about moving some of their electric utility poles. So for just an example, I've just made this up. I've made up a situation where they have a utility pole right here at the corner of this road. And then as a community, they're starting to think about, okay, well, when might this utility pole become at risk from flooding? And so currently we're looking again at that no sea level rise annual storm. If I increase to a 20-year storm, you can start to see it's still outside of that flood hazard zone. But the 100-year storm, again, what they saw kind of similar to Murbach, is starting to affect that location. And so now what we can start to think about is, well, where can we move that pole where it would be safe from floodwaters, not just today, but also with, let's say, 3 feet of sea level rise and that big storm event, right? So this is 1.5 feet. This is that 3-foot sea level rise scenario. And you can start to see that, these areas are outside of that future flood hazard zone. And so maybe we want to think about relocating that utility pole to, a different location further upslope. So we have not just the flood extent and flood depth information. Those are obviously really critical pieces of information in determining potential hazard exposure, but there are a lot of other factors that could modify or amplify the potential for risk and damage. And so that includes things like wave heights, which, sorry, 1 second here. Wave height information, which could be used to sort of think about flood, how high flood protection structures should be. Right, so I'm looking over here. How high should flood protection structures be? Which boat landing areas you might want to use in the future. The erosion and sedimentation information can, for example, help you in thinking about, if you have sewer or water distribution lines that run right along the coast, and you don't want them to, become exposed because of coastal erosion, then where might you think about relocating those? And then the last one is a product that we call velocity hazards. And this is a combination of both how deep the water is and also how quickly it's moving, right? So you can think about if you were wading across a stream, if the water is really shallow and moving quickly, it's not really a risk for you to be knocked over. And also, even if it was really high, like waist deep, but not moving very swiftly, then that also isn't going to knock you over. But you could get in a situation where even if the water was shallow, but it is moving really quickly, that becomes a hazard. And so it's that combination of both depth and how quickly the water is moving. And so that particular product, that velocity hazard product, can help you think about, maybe a bit of flooding is no big deal for, your fuel drums or some other equipment. But in a case where that water is moving really quickly, you may not, you may have impacts to boardwalks, you may have equipment that gets, picked up and moved even with just a little bit of water. So it's just a good way of thinking about how to plan where to put some of those pieces of infrastructure. Okay, so I think I just wanted to kind of close in thinking about applications. So, I've given examples of maybe one particular piece of infrastructure and how you might think about that. But we have this coastal storm modeling system product in a lot of locations in the lower 48. And so we've seen how communities have been using the information primarily for that kind of long-term planning, thinking about climate adaptation. And so this comes into a lot of kind of land use plans, hazard mitigation plans, when you're thinking about infrastructure and planning for infrastructure. And then also, been used a lot for just public engagement and communication about these potential hazards. So I have a couple of examples. This one is from Washington State, where we have a community in Whatcom County, which is in Puget Sound, that's used the information to do a county-wide vulnerability assessment to, identify all kinds of assets like homes and roads and other things important to the community, agriculture, things like that, to look at potential exposure and then to consider adaptation strategies to help make those communities more resilient in the future. And lots of other examples, especially from California, where we've had these flood hazard maps out for a long time. Everything from local to statewide in agencies have used the information for these kinds of plans. And there are two ways that we provide or deliver the hazard maps. The first is if you have your own GIS system, you can actually download the maps themselves. We provide that hazard data. There's a QR code in the URL for the Alaska data here. Currently, for Alaska, we only have 4 communities complete. That includes 3 in Norton Sound, Elim, Golovin, and Unalakleet, as well as Utqiagvik. And then we are working on more communities, about 12 to 15 that we're working on presently that we hope to complete by the end of the year or early 2027. And then we also put the information out through this web tool. It's called the Hazard Exposure Reporting and Analytics Tool, or HERA. And for Alaska, we have 2 of the tools available. We have this multi-hazard viewer and we have a coastal flooding piece that's currently available. And again, just for these 4 communities, but it will be coming out with additional communities as we complete the flood hazard maps. So I'm going to go into a demo here of the web tool. Okay, so I'm just going to walk through a couple of pieces of this. There's a lot to it, and I'll just kind of give you a little highlights tour. So the first thing I'm going to focus on is when you come to the landing page, there's a lot of information available, right? There's information to help you get started. There's a kind of a guided tour. If you're interested in where the data and the methods are, you can look kind of into more details. So there's lots of kind of help information. But if you're like me, I just like to jump right into the maps. So the first thing I'm going to look at is the multi-hazard viewer. And this is really intended as a viewer for all of these hazard products that Lee and I have talked about. So you can see we've got the products for a lot of different geographies. And now we're going to focus on Alaska. And Alaska is a little different because we really have just been able to do the modeling for kind of communities, not the entire coastline like we have for other geographies. But so I'm gonna pick Alaska. And so on the left-hand side of all of these tools in HERA is the control panel. And then usually there's a map on the right-hand side. And I'm gonna pick this most likely extent and depth as an example. And when I select that, you can see now I can click through all the different combinations of sea level rise and storms. So I'm going to zoom in here to Elim, since that was what we were looking at earlier. And see if I can get that to load. And then a couple of things I'll just orient you to while that's loading. On the right, you can zoom in and out with these buttons. My personal favorite here is you can change the background. So I like to use the satellite background. Gives me just a better picture. And then I'm going to zoom in a little bit more to the community itself here. And so it defaults to no sea level rise and that kind of average daily conditions scenario. And it shows the flood hazard for that scenario. And Elim is, up really high up on a bluff. And so typically this isn't an issue, flooding from the coast. Now, the first thing I like to do is to convert these to feet, if that's how you prefer to think about the increments of sea level rise. But then I can start to think about, okay, what does that annual storm look like? And it takes a little bit of a second here to load. And then what does the flooding look like with a 20-year storm? Again, those same kind of scenarios that we were looking at with the slides. You can just toggle through all of those through this web viewer. And then I can also, increase the sea level rise. So you're able to see all the combinations and the potential flood hazard, as well as the depth that the water is. And the depth are binned into these depth classes from, everything from less than a foot up to kind of overhead. The other piece that Lee mentioned is that we do produce a minimum and maximum flood extent. And so if I click on that, you can see basically what the potential range of in flood extent might be for any given scenario. And this accounts for factors like, what if the topography that we used in our modeling was off by a little bit? And so you could think about if you were planning for a really important piece of critical infrastructure, you might consider looking at the maximum or kind of worst case flood extent for any given scenario. And so we have that in here. And then I also mentioned that we have that velocity hazard product, again, kind of binned into these classes. And so all of that is available in the multi-hazard viewer. Currently for Alaska, we don't have groundwater information, and the shoreline change information is going to be coming at a future time. But so those are the things that you can look at basically in the multi-hazard viewer. The other thing I'll touch on very briefly is if I go back to the main thing, the coastal flooding tool. And so the coastal flooding tool really takes the flood extent, that flood footprint, and it's giving you summary information about what we call them assets, like what community, infrastructure, people, et cetera, are potentially within those flood hazard zones in any given scenario. And so I'm going to launch that. And this has a lot going on as well, and I'm just going to kind of breeze through a few highlights. The first thing again is you'll see that left panel. There's a lot more things to select now, but the first thing you want to select is what communities in Alaska. And so I'm going to focus on this Norton Sound area, and I'm going to select those 3 communities that we currently have information for in Norton Sound. And so you can see that's Golovin, that's Elim, and down here is Unalakleet. And then I'm going to pick a scenario. So say I'm interested in that 100-year water level, and I'm interested in the kind of most likely, right? So I'm not going to look at the minimum or that worst case scenario. Then down here, you see there's a bunch of different assets that we can select. And so there's information on residents, but the one I'm going to pick just for an example are roads. And so I'm going to pick all roads. And then I'm going to ignore the map for now because we showed that a lot. I'm just going to maximize these graphics. So what you're getting here are summary information about, in this case, we're looking at Elim, and the length of roads in miles within Elim that are potentially within that flood hazard zone for this scenario that I've picked, right? I'm looking at no sea level rise and 100-year storm. And then what's nice is, so it's looking like about a half a mile worth of roads, and that's about 8% of the total miles of roads within Elim. The center graph gives you information as you increase sea level, right? So you can see how that goes from about a half a mile of roads exposed up to over a mile with a high sea level rise. And then I can also see how, okay, if it just the daily or the annual storm doesn't actually have any effect on roads. It's not until you get into these larger storm events. And I can click through to look at Golovin, and I can click through to look at Unalakleet. And then I can also compare places. So I can look at all three of those communities, or any of the communities up here. Like if I wanted to add Utqiagvik, I can click on that, and I'll get either a summary, or I can change this to each individual place. So again, there's a lot of information here, and as I choose different scenarios, you'll see that the graphs change as I go up or down, choosing different scenarios. And so you can get all of this summary information. You can download all of this summary information. There's just a lot of stuff available. So I'm going to switch gears here, go back to my slides. And so, kind of in summary, the HERA tool lets you both just look at the hazard maps in that multi-hazard viewer, but then also consider, you can query certain locations, and you can start to understand what community infrastructure might be at risk, and you get these very quick summary statistics. For Alaska, we don't have all of the assets information available. What we have right now are residents, roads, and critical facilities. And again, just a reminder that currently the information is just for those 4 communities where we've completed the flood mapping. What we're hoping to include in HERA is more detailed information about building footprints, and also thinking about the depth of floodwater relative to their first floor elevations. And so this is an example that DGGS has put out with their AK Fit tool, where they've basically, they have building footprints that are the black outlines, and then they've highlighted in red the buildings that not just are within the flood footprint, but are actually that first floor elevation is flooded, right? So you can see this building right here is like a corner of it is in the flood footprint, but the water is not high enough to actually inundate the first floor elevation of that building. So we'll have hopefully some more detailed information that summarizes those elevations coming in the future. I guess kind of coming back to the arc of our project, we really have been trying to work with both our pilot communities and other kind of technical support organizations to make sure that we're delivering useful and usable products. And so we have this engagement process where, even before we started the modeling, we were working with, in particular, Elim and Unalakleet, and building relationships throughout the kind of modeling process. Right now, for the 4 communities where we have products, we're really in this, what I call the training phase, where we're doing things like this. We're doing webinars, we're doing information sessions, we're doing trainings to really make sure that people know how to access and use the flood hazard products. And then as people transition into actually doing those vulnerability assessments and kind of more detailed analyses, were also available for technical assistance. But thinking about that training phase, as Melinda mentioned, we hope if this is something that you find particularly useful for your community, and this was a lot of information that we just gave to you in a short period of time, we are going to be doing a more deeper dive at the Alaska Tribal Conference on Environmental Management at the end of March. So again, just a plug to come join us. We will have speakers from Unalakleet and Elim talking about their coastal flood experiences, and also the planning that they've been doing to think about making their communities more resilient. We're going to be joined by the Climate Adaptation Science Center staff that are here as well. And in addition to kind of a panel of speakers, we're also going to be planning to do a hands-on activity with the HERA web tool. So you'll get to, actually look at the different data and think about the kinds of questions that you can answer. So yeah, come join us. And then we've mentioned we've got 4 communities complete, but we're currently actively working on and hope to complete by the end of the year about 12 to 15 additional communities. There are a couple on this list that we may not be able to complete just because of a lack of input data, but we're doing the best we can in getting through as many of these as possible. And this includes a collaboration with the Action Project on 3 additional communities. So part of the expansion is through the Merbach disaster supplemental funding that USGS received. And that's why we're able to go beyond just those pilot communities. And with that, thank you so much. Really appreciate your time. If you are interested in more information about our larger project, the top 2 QR codes will get you to web pages that give more information. And then just another reminder about accessing the GIS data, that geospatial data, as well as the HERA web tool. And please feel free to reach out with questions. Thank you.
Great. Thank you, Maya, and thank you, Lee. That's quite a bit of information to take in. Lots of visuals there. Maybe you can go ahead and leave this up while we open up for Q&A, questions and answers. So I just welcome any of you that would like to ask some questions for either one of our guest presenters to go ahead and raise your hand, and maybe why we are waiting for those of you to collect your thoughts, I'll ask a couple of these that are in the chat already. So it looks like Lee answered this one already, but maybe if you want to expand on it. Cheryl asked, does the tool take into account the accelerated impacts of climate change, like for the 50-year storm? So I don't know, Lee, if you want to talk about that a little bit more.
Yeah, so on that slide where we had the 2 flood staffs, was separating out that 50-year storm for the first 1979 to 2020 period is derived from the model time series, hourly time series from the past. And then if we look at the hourly time series for the future runs, then we see that there is that 50-year storm is at a different level, right? It has changed. So we are accounting for the changes in the sea ice reductions, the changes in storm patterns, and the changes in wind magnitudes and sea level pressures that are anticipated to occur.
Wow, great. It looks like Catherine has another question here, and it's about submitting photos and videos to share in terms of the impacts to the locations because they're changing so fast. And I don't know if either one of you want to respond to that. I have some thoughts just being a part of working with Unalakleet, and then of course communities that are looking at relocation or managing or protecting in place, managing retreat.
You want to take that one, Lee?
I think I heard the question, if I did hear it right, about submitting photos to document all the changes that are happening. That's so valuable, so valuable. There is more for the flooding events. There's a database that's run by DGGS. You can upload. It's on the Facebook page. There is a Facebook page on it where you can upload. Exactly. Somebody put it in the chat there. Yep. For other items too that are changing so fast. There's, well, let's see. There's also at DGGS, they have a very nice shoreline change place, but I'm not sure about the photos there. Maybe somebody else can answer for that. But I think that's a great idea, and it's really, really valuable, all the things that are happening.
Maybe I'll just share also that that documentation of any of the impacts that you have is highly critical. The one thing in working with Unalakleet, who just finished their hazard mitigation plan, multi-jurisdictional hazard mitigation plan in 2023, is and you'll see Kelsey talk about this if you watch part 1 and part 2, is she takes a before, during, and after picture when she knows that there's an incoming storm or some kind of incoming impact. And that's really powerful. It's really powerful to have that presented both in a hazard mitigation plan as well as having it available when you are explaining to perhaps outside entities or agencies that you're working with, is having that before, during, and after, and then especially coupled with some of this other information that's presented here. So definitely something to consider. Okay, do we have any other questions? Anybody have any additional questions or comments?
There was one in the chat from Olivia. For the communities that I mentioned, there's lack of input data. Are there resources to start collecting the needed data to allow for future modeling? And so I was wondering if maybe Lee could talk about what are the, what is the critical input data that we lack in some of these communities?
Yeah, there have been huge strides in the last decade or so in collecting data, but we are still lacking. Particularly, one of the critical components has been topography, which have now become much improved thanks to both LiDAR collection and SFM using drones, for example. And also bathymetry is another one that's still very lacking. Bathymetry, much of the bathymetry that is available is still outdated. Again, there's been huge strides and improvements in that data, but there's many areas that are lacking in good quality bathymetry, and that has a very large control on what happens with the storm surges and the waves. And then also permafrost decay, of course, is critical, and the shoreline change also going forward to have continue that forward, because that's something that trains our models. We can use it to validate models and make better predictions for the future. So I would say those are critical data collections.
Lee, can you just explain, in case we have any new folks, what bathymetry is? Because there's so much language.
Yeah.
In much of this work, and so it's good to have that for folks who are folding in to this work.
Yeah. So bathymetry is basically the elevation of the seabed, of what it looks like underneath the water surface, and topography is what it looks like above the water surface. So we often say topobathy for the combination of the whole elevation surface.
Great. And just so you know that some of that is explained further, again, in part 1 and part 2 of this 3-part series of on coastal mapping and decision-making and planning. So are there any other questions? We have about 5 more minutes. I don't see any. Maybe Maya talked about the additional communities that are coming online with their with this work being done, and you can see Shaktuluk is one of them there, and one of our tribal liaisons who's with us. Jolene, when you see this material being developed for your communities in your region, and you, of course, experience some of these storms and heavy impacts in your own community, do you have any thoughts to share?
Looking at this model, it makes me excited. I'm excited to see what's to come and all the data that they'll be collecting for each of our communities, especially on the coast. So I think it'll be very useful information for our tribes to use as they plan for their communities.
Great. Thank you. Yeah, I think being able to explain locally to people in terms of some of the impacts, which of course people are their own local experts, I think that's really helpful. And at the same time, having these and being able to think down the road, especially many years ahead, I think will help in both the local conversation as well, of course, as well as working with those outside of the community. And I see that Veronica has a question here, which is something that, of course, we've seen happen with communities that have been hit with our heavy storms lately. And she says, our community is finally updating the roads in our community. I have concern for another fish camp that my community, or maybe in my community, will I be able to use the Hera tool? Do you want to take that?
Veronica, I'm not sure which community in particular, but if it's one of the ones that we have on our list, then I would say for sure within where most of the communities sort of, housing and kind of most of the infrastructure is located. We are sometimes not able to capture the fish camps if they're really far away from the, again, the sort of like heart of community infrastructure. And that is just because of the lack of that topography data that Lee mentioned. So for instance, we have Elim, but they have a fish camp that is well outside of that location. And so we don't have the mapping information for the fish camp. So I think it depends a little bit on which community and where, but happy to follow up with more details.
Mm-hmm. And I would add to this is the kind of feedback that we like to know where you see as an important area. So because sometimes we can extend the model to include areas that we may not know are important. So if we know that ahead at the start, which we did that before with Unalakleet, we from feedback from community members, we understood that there was an area further up coast that was of interest, and so we extended the model domain to meet those needs. So that's all good thing to know. So night mute and okay, we may reach back out to you when we get to that point. If that's all right with you.
Okay. Well, great. I have one other quick announcement. I'm really happy that we had our presenters today, and thank you so much. Oh, there was one other quick one. And maybe you just answered it that no, it doesn't look like it. Too much rain and landslides can be covered. Can these be covered in the Hera tool? Did you see that?
We do not currently have those additional hazards in the Hera tool. This is really focused on coastal flooding and erosion.
Okay. Well, that sort of leads into if I can get to my other screen, and maybe you can see this here, an announcement that that does relate, and that is For those of you, maybe you learned of this if you were at the recent Alaska Forum, but the statewide threat assessment is currently looking to be updated. Many of you may know that this looks at primarily the threat of permafrost thaw, erosion, and flooding across many communities. And it was a 2019 report. That report is being updated by Denali Commission, and they've contracted with this company to do outreach and to do the update. They're having a public meeting here February 26th in Fairbanks. They've had one in Anchorage and another site previously. But I could not find a lot of information on it, but you'll see there's a contact person here. And if you want to find out more information, if they're going to have any additional outreach, please contact the contractor there. And then I just want to put a shout out to one of our other programs. It's the Inspiring Girls Expedition. Of course, we like to highlight bringing our next generation along and learning about science and some of the impacts we're having across our lands. And so this is a program that's very popular, and the applications are open for young women right now. Girls on Ice and Girls on the Water are two of them that are happening this summer. So thank you all for being here today, and it's great to see folks attend. Great turnout, and I just am grateful for our presenters, Maya and Lee, and the work you're doing, and all of you at the community level who's contributing, and other agencies that are working together. It's significant and critical work. So take care, have a wonderful lunch, and we will see you hopefully next month.